So today's lesson is the absolute value function. I've already posted some videos for the introduction. Let's talk about the absolute value in general first before we talk about how to solve the equations. So the meaning of absolute value is basically it represents a distance. So for example, if we have the number line right here, this is the 0, this is 1 and negative 1 in here, this is 2, 3, 4, let's say negative 2, negative 3, negative 4, so infinity here. Okay, let's say we're going to talk about 3 steps. So someone or something moved through 3 steps, to the right and 3 steps to the left. The way of writing it, so what we're going to describe in here is 3 distance away from 0. So this is basically the meaning of absolute value. Absolute value always talks about how far this thing is, or this x is, from the 0. So if we're going to write this, we will be saying that 3 and then the notation of it, which are 2 straight lines like this, which is called bar, which you can find it on the keyboard next to the enter key or above it in some keyboards. That is equal to 3. And also negative 3, the absolute value of negative 3 is equal to 3 as well. Now, the general way of writing any function that includes an absolute value, or the function of absolute value, is this way. So if we say x, the absolute value of x, okay, is equal to, okay, here we have 2, or we can put it on 3. I will show you how later. Now, usually it's just two conditions, or 2 possible answers. The possible one is if x, now if it's the absolute value of x, then it is equal to x if x is greater than or equal to 0. Because like we did here, when the number inside the absolute notation, the absolute value notation, is positive, it gives you a positive value at the end. But if it's negative, it gives you a negative value. So there's always 2 possible answers. I will see how we're going to use this in equations. Now, it is equal to negative x if x is less than 0. Okay. In some books, you might find it like this. You might find it like x, the absolute value of x, is equal to, and then you have 3 conditions, or 3 possible answers, which is the same as this, just different way of writing it. So it can be x, and the 0 is here, and the negative x is here. So this, if x is greater than 0, this is equal to 0, or x equal to 0, and here it is just when x is less than 0. So the only difference is actually just putting 0 individually. It's not really different. So okay, let's talk about some properties that you might face, or you might need to use. Okay, now here, for example, if we said that, okay, the first property is a, which is just a number. Okay, a is a real number. I'm just going to write it as a is a real number. That's the first thing. Now, a, or the absolute value of a, is always greater than or equal to 0. Now I'm talking about the absolute value of a, not a itself. Okay, now let's say that this is our first property. Our second property is the absolute value of a is equal to the square root of a squared. Do you know why? This property shows you that the number here inside the square root gives you the 2 solutions of positive and negative the number, which can be represented as a, the absolute value of a is equal to, it's equal to it's equal to a, but this a is either positive or negative a, and vice versa. The positive and negative a gives you the absolute value of a. Okay, and this is one very important property, which is the absolute value of a times b, where a and b both are real numbers. Okay, the absolute value of a times b is equal to the absolute value of a times the absolute value of b. Okay, because when we multiply numbers, the sign isn't really important in this case because it's just multiplication. So it doesn't matter if you get positive or negative because we're talking about distance again. It's similar to the idea of having okay, do you remember in physics you took something called distance and we took something called displacement? Now this is exactly what we're talking about here. Here we're talking about the distance, not the displacement, because the displacement gives us different answers. Now here's an example on this, the displacement and the distance. So if, let's say we have this, which is block A, and this is block B, and this is block C, and I'm going to write the distances here. So let's say this is 2 meters, for example, and this is 3 meters. Okay, an object or a person or a ball or anything just moved from A to B, then from B to C, and then they went back to B. So let's say this is a shop. So someone went from his house into the school, for example, and then they went to the shop, and then they bought some things, and they went back to school. Now, if we're going to do this, if we're going to find the displacement of this person, now the displacement is equal to the first step, which he moved from A to B, so that's 2, and then he moved to C, which is +3, and then he went back to B, which is -3. So the displacement of this person is 2. But if we're going to talk about the distance that he actually walked, okay, the distance that this person walked is 2 plus the 3 meter, and then even if he went back, we're not going to use the negative in this case because we're talking about how much he walked, so it's +3. Okay, which gives us in this case 8 meters. Do you see the difference here? Now 8 here gives us the absolute value, or the meaning of absolute value, the concept of absolute value, which is talking about a distance. We're not talking about displacement here. So it's very similar. If we took the displacement and we moved each number individually into an absolute value number, we're going to get the same number here, which is the distance, because if we took the absolute value of -3, we will get 3 in here. Okay, so let's have an example of how to use these meanings and these properties into solving equations. Okay, let's say we have here's a simple example. We have x plus 2, the absolute value of x plus 2 equals 5. Now how can we find the value of x? How can we solve for x in this case? Now this is not just a normal equation that we're going to solve for x for. This is an absolute value, so we're going to use first the the original, or yeah, the original form of writing an absolute value. We already said that the absolute value x, that's f of x, equals the absolute value of x equals to x if x is greater than or equal 0, and it's equal to negative x if x is less than 0. We're going to do exactly the same once we have an absolute value equation like this one. So instead of x, we're going to put anything that is inside the notation of absolute value. What is inside here is x plus 2. So we're going to do the absolute value of x plus 2 is equal to, here we have two cases. Case number one is x plus 2, okay, if x plus 2 is greater than 5, which means 5 is positive. We can just write it as plus 5. So it is equal to, so here I'm going to write it here, x plus 2 is equal to 5. That's case number one. Okay. Case number two is x plus 2 in negative. Okay. Where x plus 2 is less than 5. Which means that x, in here, case number 2, x plus 2 equal to negative 5. Let's see how to solve this. First, here we have x plus 2 equals 5, which means x is equal to 5 minus 2, which means x is equal to 3. Now this is the first value that we get. In the second case, we have x plus 2 is equal to negative 5, which means that the whole number here is less than 0. And here we will get a negative number, which means x is equal to negative 5, negative 2, which means x is equal to negative 7. So these are the two answers that we get out of this equation. Okay, now in the next video we will be talking about graphing absolute values, and also I will be solving some examples for finding the inverse of a function using composition, because I got some questions about that. If you have any specific questions about the previous lessons, please send them to me so we can prepare another video for them. Okay, have a good day. Bye bye.